Chapter 2.3, the product and quotient rules and higher order derivatives. Day 1, the product rule. Review. Find these derivatives. Number 1, y equals 2x squared minus 5x plus 7. Straightforward using the power rule, constant multiple, and the sum and difference rule, we see that our derivative dy dx is 4x because 2 times 2 is 4. Power down to get the power of 1 minus 5. The derivative of 7, which is constant, is 0. Number 2, y equals x plus 3 over x. We'll do this as a 2 on 1. We'll split this into two fractions. X over x, which is 1. 3 over x, which is 3x to the negative 1. And then we can do our y prime, our derivative. Derivative of 1 is 0. Apply the power rule and the constant multiple rule. We get negative 3x, power negative 1 down to negative 2. Number 3, f of x equals x plus 4 times 3x plus 7. Well, first we need to FOIL that out. We'll go first 3x squared, outside 7x, inside 12x. 12x and 7x is 19x. And then last, 4 times 7 is 28. And now we can use the same rule we've used on the last two problems. We'll get 6x plus 19. Now those weren't too difficult. However, they could get a little easier. And what we're going to talk about today is a method to do that. The first one, pretty straightforward. The second and third one, there's other ways we can do. We don't have to multiply it out first. And that is the product rule. The product rule says if we have a function, h, that is a multiplication of two functions, f and g, we can find the derivative of h. H prime is the first function times the derivative of the second function plus the second function times the derivative of the first function. Or if h of x equals f of x times g of x, h prime is f of x times g prime of x plus g of x times f prime of x. There's a handy little proof in your book if you'd like to see a little proof of this. Let's apply it. All right? F of x equals x cubed minus 3x times the function 2x squared plus 3x plus 5. Now we can easily see that we have two separate functions here. All right? We got the function that I highlighted in yellow and the function that I highlighted in green. Well, the product rule, when I'm multiplying two functions, to take the derivative, I'm going to take the first function times the derivative of the second function. So the first function I'm just going to leave alone in this first step. I'm going to multiply that by the derivative of the second one. 4x plus 3 plus, now I take the second one and leave it alone. 2x squared plus 3x plus 5, and then take that times the derivative of the first. And there's my derivative for f. I did not have to multiply that out. If I did, I would have to do 6 individual terms, combine like terms, and simplify it. But applying the product rule, I can just go straight to the derivative. Let's look at this one. F of x equals cube root of x times the quantity cube root of x plus 3. First step, let's rewrite this without the radicals. So we'll use fractional exponents. Now if you wanted, you could distribute and then take the derivative, or applying the product rule, f prime is first times the derivative of second, 1/2 x to the negative 1/2 plus 0, plus the second function times the derivative of the first, 1/3 x to the negative 2/3. So we can eliminate the simplification step in these derivatives. F of x equals sine x over x. All right, this one, we need to do a little rewrite first. Remember, dividing by x is the same as multiplying by the inverse. So let's rewrite this as f of x equals x inverse, x to the negative 1, times the sine of x. And then we can take and apply our product rule. There's our first function. There's our second function. And so our derivative, f prime, will be our first function times the derivative of our second function, the derivative of sine is cosine, plus our second function times the derivative of our first function. And we can leave it like that, or we can rewrite it. I'm going to leave it like that. What do we do when there's three functions? All right, we got three functions hiding out here. All right. Well, we're going to just apply the product rule 3 times. In each step, you want to have one function be derived and the other two stay the same. So our derivative here will be the first, let's combine the first two, x squared minus x times x squared plus 1, times the derivative of the second, 2x plus 1. So what I did here, I took the derivative of the light blue. On the third step, on the second step, I'm going to keep the two outside ones. I'm going to take the derivative of the middle one. And on my last step, I'm going to keep the two last ones and take the derivative of the first. So if there's 3 steps to the product rule, you need to keep 2 of them, 2 of the functions on each one, and take the derivative of the other one on each step. Y equals sine of x squared. All right, this is just one function. How do you apply a product rule to one function? Well, squaring something means multiplying it by itself, so we can really think of this as sine x times sine x. And then when we do that, this is our first, sine x is our first, and sine x is our second. So what we want to do, we'll take our first function times the derivative of our second, plus our second function times the derivative of our first. And if you want, you can simplify. So in conclusion, when you have 2 functions that are being multiplied, suppose f of x equals g of x times h of x. The derivative for f will be the first function, g of x times h prime of x, plus h of x times g prime of x. First derivative of the second plus second derivative of the first.